So here's an example on two-tail tests. The question reads, records show that the proportion of trees in a wood that suffers from a particular leaf disease is 15%. Sam thinks that recent weather conditions might have affected this proportion. It's the keyword here because she doesn't know whether that's reduced the number of trees that have the disease or increased the number of trees that have the disease. She examines a random sample of 20 of the trees. Using a 10% significance level, find the critical region for a two-tail test of Sam's theory. The probability of rejection in each tail should be as close to 0.05 as possible. Now this is something new for you all. You haven't done any question yet out of the examples I've done where we've been told to keep the probability of rejection as close to 0.05 as possible. We've always done less than the significance level. In this case, you can already tell the significance level of 10% has been split up in half and therefore giving you 5% on either tail. To start with the question, we have to make sure we specify what x is going to be, what the random variable is going to be, and x is the number of trees that suffer from a particular leaf disease out of 20. The null hypothesis is the probability of a tree getting a leaf disease is 15% in that particular wood, in that particular forest. The null hypothesis is that the proportion of those trees is not 15%, but we don't know which way it's going to go, so that's the not equal to representation. The distribution is x is going to be estimated using binomial, n is 20, 0.15. I briefly talked about expected outcomes in the previous video. So if we were looking at expected outcomes, if it was according to the current probability, which is 15%, if we do 15% of 20, that gives us 3. So we would expect 3 trees to have that disease. Okay, now what we have to do is we have to check. According to the significance level, when we split it up, it gets 0.05 here and 0.05 here, which is 5% on either way. What we're trying to find out is this rejection region. So that means how many trees would have had to have the disease for us to say the proportion has changed. Obviously, in this case, it would have reduced. So as expected, we're expecting 3 trees to have the disease. But for Sam's claim that the proportion has changed to stand true, the number of trees that would have the disease would have to be significantly less. So that means something like maybe 2, 1, or 0. And if we are saying the number of proportion of trees that have the disease have increased, i.e. changed, but in this tail, then that would mean more than 3. So that could be anything. That could be 4, 5, 6, 7, 8, all the way up to 20. What we're trying to find out is where does it become significant enough for Sam's claim to remain true. Now, to test this type of question, to find the critical region, rather than using the variable mode where you'll have to try loads of different values, you put your list mode in the calculator. Bearing in mind in this question, we have to make sure that the probability of rejection is as close to 0.05 as possible. So I've done the lower tail first. The probability that 1 tree or less have the disease comes out to be that on the calculator. I look at the distance between that number and 0.05. What I'm trying to make sure is that distance is obviously the least, because I'm trying to get that value closest to 0.05. Because this value was greater than 0.05, I didn't accept it. But if that value, if that distance was lower than this distance here, then I would have to go with this even though it's greater than 0.05. I look at the probability that 0 or less trees, just 0 tree, have the disease, and the probability is less than 0.05, which means it would lead us to reject the null. And also the distance, this value is closer to 0.05. That means this is the value we'd go for on the lower tail. That means the rejection region here is actually 0 trees. Looking at the upper tail, we're looking at 6 or more trees having the disease. Now remember that binomial doesn't look at more than, it looks at less than. So we rewrite the probability as 1 minus the probability of x is less than or equal to 5, which gives me this probability here. Now that is greater than 0.05. So I go on to the next value. I find out the probability there, and that is less than 0.05. But again, because we need to make sure the probability is closest to 0.05, I have to look at the distances between the numbers. Now, although this probability is greater than 0.05, this one is closer to 0.05. Therefore, this is the one that we would have to accept. Okay, so the critical values are 0 and 6. These are the values. Now I know my diagram is a little bit off because 0 is there and our critical region is 0. However, that's sort of the understanding. And 6 is here. That means if Sam was to find that out of those 20 trees, 0 tree had the disease, that is significant for her to go with her claim that the number of trees that have the disease, they have changed because of the recent weather conditions. And if she was to find 6 or more trees have got the disease, then again, it's changed. It's gone more, obviously, in that case. The critical region is x is 0 and x is greater than or equal to 6. Part B in this question says to find the actual significance level of the test based on your critical region. The actual significance level is found by adding the probabilities under the null hypothesis of the test statistic falling in each part of the critical region. Because it's a two-tailed test, we would add the probabilities from each side of the critical region, and that comes out to 10.61%. Because we went above the significance level, it means the actual significance level of our test would be higher than the significance level as well. However, normally we would expect that to be lower. Sam finds that 8 of the sample trees have the leaf disease. Comment on this finding. Now, this observed value of 8 is within the critical region because our critical region is greater than or equal to 6. And then you would have to, in addition to commenting on the fact that it's within the critical region, you have to give your conclusion is that there is enough evidence at 10% level of significance to reject the null and support Sam's claim that there has been a change in the proportion of affected trees. Right, now is time for you to try 3 questions which you'll find under the assignment on Google Classroom. Good luck, take care and stay safe.